Hello and welcome to another calculus instructional video. This video is about implicit differentiation. Implicit differentiation is a special type of derivation that we use. It's a variation on the chain rule, and it's used for when an expression is written implicitly. So, let's take a look at this equation written up here. X squared plus y squared equals 25. This is written implicitly. Written implicitly means that it's either a function of x and y, and that you can't separate the two, or it's also sometimes used when you really don't want to solve for y because it would make it look really ugly. In this example, if we wanted to solve for y, we'd have to take a square root, and there would be an x squared minus 25 under the square root, and it would look really ugly, and you don't want to differentiate that because it gets really complicated. So it's easier to differentiate implicitly. Let's take a look at how we do that. Implicit differentiation, we're going to take the derivative of both sides of this equation, and we're going to say d by dx of x squared plus y squared equals d by dx of 25. d by dx of 25 we know is going to be 0, but we now need to take the derivative of x squared plus y squared. We can break this down, so we're taking the derivative of x squared plus the derivative of y squared, and we know that the derivative of x squared is going to be 2x. But how about the derivative with respect to x of y squared? We can apply a special case of the chain rule that we use in implicit differentiation and take the derivative with respect to y and multiply by y prime. And then that is implicit differentiation. We can solve this for y prime as the final step and get y prime equals minus 2x divided by 2y, which reduces to negative x over y. Now, let's take a look at this in an example problem. This is actually written incorrectly because it is not a function of x alone, so we're going to say that it equals 0, and we're going to take the derivative of this. Now, when we take the derivative of the first term, we're going to have to use the product rule again. And the product rule, you can refer to an earlier video to figure out what the product rule is if you're a little sketchy on that. But what we're going to do is we're going to take the derivative of 3x multiplied by y, and then take the derivative of y with respect to x and multiply by 3x. So, we're going to take the derivative of 3x, which is 3, and multiply by y, plus 3x times the derivative of y, which is y prime. And then we're going to add the derivative of 4x, which is 4. The derivative of 0 is 0. Then we're going to simplify. We'll have 3y plus 3x y prime plus 4 equals 0. And then when we solve for y prime to finish it off, we'll have y prime equals minus 4 minus 3y minus 3y all over 3x. That is the solution to our problem.